sine of pi over 12, yeah. So the first thing to notice is that it's really the sine of 30 over 2. 30 over 2. So this theta, or this angle up here, it's double this one in most cases. Okay, so the way the formula works, and maybe we'll just use this problem as an example here. Just refresh the screen here. So you'd get something like this on a tester quiz. It'd say find the sine of 15 degrees. You would have your formula figured out. You're like, there it is. I know it really well. You have to know what theta is, okay? What the angle is. Now it's not 15 degrees. Okay, so what you can do is you can set this part equal to this part. So you can set theta over 2 equal to 15, or like I was showing you in the earlier, you kind of know it. You're like, oh, it must be 30. 15 times 2 equals 30. So that theta is really important, because that's what's going to end up going into this formula over here on the right.
Mm-hmm.
Okay, so there's really two parts to the formula. The first part is this square root stuff. That's the first part, and then the second part is this plus or minus. So we're gonna tackle the square root part. So the sine of 15 degrees, we'll do 1 degree problem, equals plus or minus the square root 1 minus the cosine of 30 degrees over 2. Okay, so you gotta know what the actual angle is, double that, put it into the formula here. Right now, do you have cosine of 30 figured out on your unit circle? This is key. There's no way to do this without knowing this information. So the cosine of 30 is the x value. The x value there is root 3 over 2, comma 1/2. Maybe we can spend some time today talking about how to do a unit circle at some point.
Yeah.
All right. So we're going to substitute that in for cosine 30. So it's 1 minus square root 3 over 2. That's going in for cosine 30, all over 2. And then kind of a plus or minus. So from here, the part under the roots, it's not really trigonometry anymore or pre-calculus. It's just manipulating an equation and seeing what you come up with. We should look at that a little bit here. So in the top here, you've got a 1. It's really 1 over 1. Maybe put that off to the right here. You want to make a common denominator, so you multiply the top and bottom by 2. Okay. And then so this becomes 2 minus square root of 3 over 2. Okay, so it's root 2 minus square root of 3 over 2, all over 2. So from here, you can multiply the top and bottom by the reciprocal, the 1/2 here. So basically that 2 goes into the bottom there. So it becomes the square root of 2 minus square root of 3 over 4. And then you can apply the square root to the top and the bottom. So it becomes the square root of 2 minus square root of 3 over 2.
Okay.
Okay, but that's only the part, it's only the part, this first part. This plus or minus is kind of 50% of the problem here. Okay, so how do you determine that? Well, you're finding the sine of, well, how do I want to say this? Your original angle, well, let me do it this way, say it this way. What quadrant is 15 degrees in? Let's do it that way.
Quadrant 1.
Quadrant 1, right? No, that's not too hard. Now, everything in quadrant 1 is positive. So they're all positive there. So you now have your answer. It is positive. But it depends on which quadrant you're in. That's the real answer.
Okay.
And most of the time you're going to be in a positive quadrant, but we could not say for sure. All right. So let's do another one here. Let's say I wanted the cosine of 167.5 degrees. Okay. Now, you as a math student are supposed to recognize, oh, I don't know this value. It's not on the unit circle. But is double it on the unit circle? Is 2 times 167.5, is that on the unit circle?
Yes.
It is, yeah. And so that kind of tells you, oh, this is probably a double angle formula, because this is really cosine of 330 divided by 2. So I'm going to grab the formula for cosine. And you'll notice it's really, really similar to sine. There's only one difference between it and sine. So here's the formula for sine somewhere. Maybe it's better to look at it up here. So the only difference between sine and cosine is the operator, minus and then the plus. So that it's not too bad to remember if you have to memorize these. Okay. All right. So the idea here is that the theta, the value of theta, it's not the original value. It's not the 167.5. It's actually the 330. That's key, because you're gonna use it inside the square root here. You're gonna have to find the cosine of whatever it is, so it's got to work out nicely.
Right.
So you're just sorry, go ahead.
No, it's like it's irrelevant to this. I'll just wait. I still
Okay.
have it in my brain.
All right. So to do this calculation now, since you know that the angle is 330, it's plus or minus square root of 1 plus cosine 330 over 2, like that. And so again, you got to know your unit circle. You got to know, what's the cosine of root of 330. It is, again, square root of 3 over 2. So this becomes plus or minus 1 plus square root of 3 over 2 all over 2, like that. Now, because this is it's almost exactly the same as the last problem, except it was a minus instead of a it's exactly the same. So we don't need to repeat all the steps, but you can see it reduces down to this. So it reduces to plus or minus square root 2 plus square root of 3 all over 2, like that. Now, you got to figure out which quadrant you're in. Is it? And so you go back to the original angle. You don't go to the 330. You go back to your original. Which quadrant is 167.5 in?
Quadrant 2.
Quadrant 2. So in quadrant 2, all students take calculus except Paige, right? You're not taking calculus.
No.
You can tell your teacher that every time they say that. What this tells you is that sine is positive in the second quadrant. The S means sine is positive, but everything else is negative. So that means cosine in the second quadrant is negative, which is why you select the negative.
Right.
All right, now there are other ways that these half angle problems could be presented. Is this consistent with what you've seen in class, or are you seeing other things?
It's consistent.
Okay. All right. So there's only so many that they can ask you, because it's like I don't want to say it, like only some of them are known. Like what's the tangent of 22.5 degrees? All right. So the idea here is that that is not on the unit circle, is it?
No.
No. But is the double of that angle on the unit circle?
Yes. No. Yes. I don't know.
Yeah, it's 45, right? 22.5 doubled
No.
is 45. So that tells you that 45 over 2, that's what you're really doing. Like you're just making you're just rewriting this 22.5 in a non-simplified way.
Okay.
So now you can go to your tangent formula here. Okay. What is the value of theta now in your problem here?
45.
45, good. So 45, 45. Okay, so this becomes plus or minus square root 1 minus cosine 45, 1 plus the cosine of 45. So now you got to go to your unit circle and give me those values. Can you tell me what the cosine of 45 is?
I can. Is it square root 2 over 2?
Yes. This one's pretty awful. That's why we're doing it together. It's root 2 over 2 over 1 plus root 2 over 2. Okay, and what this means or requires of you is you have to work on the top and the bottom to rationalize it.
Right.
So on the it's times 2 on both of these, top and bottom. So it becomes 2 minus root 2 on the top over 2 over 2 plus root 2 on the bottom over 2.
Mm.
Because once you make the common denominator, you can just keep the one denominator. Okay. So what do we have here? The bottoms cancel. Do you see that the 2's on the bottom would cancel? If that's
Yeah,
not
I see
clear,
that.
let me know.
I see that.
Okay. So now this is where there's kind of almost, it's like it depends on the teacher. You're at a place where it's 2 minus root 2 over 2 plus root 2. And there's not a ton of things you can do from this point. You can rationalize the bottom, but this is like the one time where you're okay to leave roots inside roots. Besides, we're kind of getting away from what you need to work on anyway. Now the last part, right? The plus or minus. So you gotta go back and figure out, well, what quadrant was I in with the original angle? 22.5. Which quadrant is that?
Quadrant 1.
Quadrant 1. Everything is positive in quadrant 1. So we go with selecting the the positive there. All right, let me see if I can find any other problems that I'm missing that are kind of these half angle formula problems.
Okay.
So I'm not seeing any other ones kind of that jump out to me, but the one of the other ways this is used is they would ask you something like the following. They would say the cosine of theta equals 4/5, and they might tell you that you are in quadrant 1,
Mm-hmm.
and then they would ask you, what is the sine of theta over 2? Is this the kind of problem that you've seen in class potentially?
Yeah.
Okay, so we should look at some of these now. They sometimes work out a little nicer than the ones we were just doing. So this quadrant's really important, and there's a couple of ways that they can give you the quadrant. But that tells you the triangle. So there's, depending on which quadrant you're in, there's 4 triangles, and they all look like this. So notice it looks kind of like a bow tie,
Mm-hmm.
and the idea is that the reference angle is always made with the x-axis. So depending on which quadrant you're in, this is the you would have to pick the triangle based on the quadrant. So since you're in quadrant 1, you're going to draw a triangle that looks like this, that matches the quadrant 1 triangle. The angle is always the base angle.
Right.
And then you label the sides. So cosine is adjacent over hypotenuse. And then you're supposed to find the other side. Now, maybe you can tell me the other side or use Pythagorean theorem to do that.
It's 3.
It's 3, yeah. Now, this is important because you may need the sine of the angle or the cosine of the angle or something like that, depending on the problem. Like sometimes they ask you more than just sine of this, but now we can go down and grab your sine formula. Okay, so this problem is asked for the sine of theta over 2, and from your reference sheet, you're supposed to be able to say, oh, that's equal to plus or minus square root of 1 minus cosine theta. So 1 minus 4/5 over 2. Now this one reduces a lot nicer. Okay, the numerator is 5/5 minus 4/5 over 2. Which becomes 1/5 over 2. And so that's 1/10. So it's 1/10 plus or minus the square root of that. Now this one you can rationalize. This one you would take the root of the top and the root of the bottom. And you do have to rationalize multiplying the top and bottom by root 10. So that's root 10 over 10. And still it's plus or minus, like we haven't decided that yet. All right, so here's how you decide whether it's plus or minus. Again, you go back to the quadrant you're in. You're in the first quadrant, okay? But this one's a little different. You have to decide, well, where would you be if you were in half the angle? And you might be like, well, what do you mean by that? Well, it's 0 because you divide 0 by 2, and then 90 divided by 2 is 45. So the half angle we know is between 0 and 45, still in quadrant 1.
Right.
Right. So because you're in quadrant 1, you know that all of them are positive. I know it's probably maybe seems like, well, why is he doing all that work? They're positive most of the time, or like, are they? Can I just always guess positive? I mean, you can, but there's always going to be an exception. So this isn't a kind of a problem you've seen in class
Um,
or not? Or are they more like the ones that we were doing up here with the angles?
I've seen both.
Okay. I mean, both are in play. Both are fair. Okay, let's come up with another one here. All right, so let's say that the tangent of theta equals minus 4/3. Okay, and then I'll just tell you that you're in the second quadrant. So I'll just say the 90 less than or equal to theta is less than or equal to 180. So this, they won't always tell you that, but 0, 90, 180, 270. So if they're saying you're between 90 and 180, you're over in the second quadrant. All right, so again, you got to draw that triangle. So here's the triangle this time. Doesn't have to be drawn in terms of like the side lengths being right or wrong, but you just got to have the right like reference with the axis. So from here, your angle is right here. Can you tell me which side is the 4 or the 3 or the -4 or the -3? Which is it? And it does matter because it's how you're getting to this point here in the top left.
The 3 is the. I don't know how to say it. The 3 is like the side.
Okay, let's do A, B, and C. Which is give me some labels here. I can see how that would be hard. Like the
B.
what's B?
3.
So remember, tangent is opposite over.
Oh, opposite over adjacent.
Yes.
So it's. Hang on, I gotta think. Opposite over adjacent. A.
It is. It is. So B. You might think that B is -4, but the problem is you can't go negative to go up. So this is one of those sort of like, it's a little bit deceptive. It's really this, because 4 over -3 simplifies to -4 over 3. All right, now what is the hypotenuse?
5.
5. Okay, good. All right, now I haven't told you what I want here. Let's say I want the sine of theta over 2 this time. The sine of theta over 2. All right, so we got to go back and grab the formula for that one. Did I say sine? I'm sorry. We did that. We did it. Let's do cosine. Trying to mix them up here. All right, so here's the formula. And we're no longer like worried about doubling the angle because we actually don't know the angle. That's what's maybe kind of odd here is like I was giving you the angle as a number. Now we're just talking about it as a symbol. So the formula, you just need the cosine of theta. What is the cosine of theta in this problem?
Oh my god, my brain's lagging.
Adjacent over hypotenuse. That's a
Yeah.
hint. That's a hint.
-3/5.
-3/5. Good. So that's going to go into the cosine there. All right. So let's start by writing that down here. So it's plus or minus square root 1 plus -3/5 over 2. So what I'd like you to do is to simplify the part inside the root for me. See how you're doing on that. This one's just numerical, no roots.
I got it as √5/5. If that's right. I don't know.
Okay, so it's 5/5 minus 3/5 all over 2. And so that becomes 2/5 over 2.
Mm-hmm.
And of course, there's the square root the whole time. So this 2 always goes to the bottom, which cancels with the 2 up top. So it's this, and then it's √1 over √5, 1 over √5. And then I think I heard you rationalize this correctly.
Well,
So √5 over 5 is your final answer. All right, so now that we know that part, we have to decide whether it's plus or minus. Okay. So this I think is probably the more confusing part. Your original angle though, your original angle is between 90 and 180. So when you divide it by 2, you're now between 45 and 90. Okay, so which quadrant is that in when you're between 45 and 90?
between 45
Yeah,
1.
it's in 1. And it's, more specifically, it's in this kind of pizza slice here area. And everything is positive there. Everything is positive there.
Hmm.
So that's until we see one where it's not like that. I think we had one earlier, but sometimes it's like why is it is mostly positive, but there will be that exception on there. All right, so we're a little over halfway. We can continue working on this. I can provide more problems like this for us to work on. Is there another topic though you'd like some more discussion about?
Let me look.
Okay.
Calculate.
Double angles are also often taught here, so it kind of related.
Yeah. I'm just checking what she put in the calendar. Oh, it's like She didn't teach us this, but it's gonna be on the test. It's like inverse of cosine and then in parentheses sine negative pi over 3.
Like this.
Uh, mm, hang on. Yeah.
Okay, lovely. There's so much here. There's so much here, Paige. I, you know, I, okay. So there's part one. Part one is sine of minus pi over 3. Can you tell me that? Even if you look at the unit circle, that's okay, but can you tell me that one?
Yeah, hang on, I gotta. It's root 3 over 2.
Okay. Any other changes to that you want to make?
Oh, negative. Root
Yes,
3.
there you go. There you go. Okay. So that's kind of like this interior piece. Remember like when you're doing composition f of g of x?
Yeah.
That's kind of like you just did the inner part here. So now it's the cosine inverse of minus square root of 3 over 2. Okay. Now I'm gonna type this next part.
Okay.
So to answer this, you're answering the following question. It's kind of like a Jeopardy-ish type thing. It says, for what angle is the cosine of that angle equal to, this is where I go back to the pen, minus root 3 over 2. So you're essentially trying to solve the problem of cosine of what angle equals minus root 3 over 2. So the answer is an angle.
Mm.
So I want you to go to your unit circle and tell me all the places where the x value, because cosine is the x value, is minus root 3 over 2.
5 pi over 6, 7 pi over 6.
Yes. So there's two answers. And you might think, oh, I've got it. I'm done. Unfortunately, you're not. Cosine inverse is only defined from 0 to pi, which means that you have to exclude one of your answers, whichever answer is not between 0 and pi. So that excludes this one.
Hmm.
So it's like more stuff to remember. There's all these like little bends in the learning here. So let's do another one though. Let's do another one here. Let's go cosine inverse of tangent of minus pi over 4. What is tangent of pi over 4?
It is one.
It is 1, yeah. So the next part is asking you to figure out the cosine of what angle equals 1. Basically, where on the unit circle are you where the x value is 1?
Um, 2 pi.
Okay, so that is true. Like what you just said is true. And you know, maybe by now know that isn't the right answer because unfortunately they want it from this interval, 0 to pi. So even though your answer is true, it's not the answer to this problem. Your answer has to be from 0 to pi. So it would actually be just 0.
Okay.
Now, I know that's like a small little thing, but it does matter. It really does matter. All right, let's do another one here. Let's go cosine inverse of cosine 7 pi over 6. What's the first thing to calculate here?
Cosine 7 pi over 6.
Okay. Can you tell me the what that is on the unit circle, please?
Yeah. It is 1/2. No, not 1/2. Negative root 3 over 2.
Negative root 3 over 2. Good. So this is now the cosine inverse of minus root 3 over 2. So what this is really asking is the cosine of what angle equals negative root 3 over 2. Now you just gave me one of the angles. One of the angles is right there, 7 pi over 6. But the problem is you're restricted to 0 to pi. So is there another angle where the cosine of that angle is minus root 3 over 2?
At 5 pi over 6.
5 pi over 6. And is 5 pi over 6 between 0 and pi?
Yeah.
Yes. So you have your answer there. So your answer is this equals 5 pi over 6. So the steps are you first do kind of the nested inside part first. Then you figure out where you get those two angles from, and you have to pick the one from 0 to pi. Now, unfortunately, there's more to do here because sine inverse problems, they're valid from this interval in your unit circle, which is minus pi over 2 to pi over 2. This is where it gets even more confusing, unfortunately. So let's go the cosine of pi over 4. Something like this. We'll do a problem like this now. So the first step here is to determine the cosine of pi over 4. Can you tell me that?
It is root 2 over 2.
Here it is. This is sine inverse of root 2 over 2. So you're now looking for where the sine of a certain angle is root 2 over 2. Basically, where's the y value? Root 2 over 2.
3 pi over 4.
Okay, so there's a couple of places. There's pi over 4 and 3 pi over 4.
Yeah.
Which of those fit between minus pi over 2 and pi over 2?
Pi over 4.
Pi over 4. So that's your answer. That's the easy case. That's the one where everything works out nice. And we'll be moving on from that here into a much harder case. So, but the idea is the same. You always find it, put the number in, figure out where that is on the unit circle, and figure out which one is in your interval that you like. So let's try another one here. Sine inverse of cosine 2 pi over 3.
Negative 1/2.
So cosine is negative 1/2 here. So now you have to figure out where is sine equal to negative 1/2.
Mm. 7
Where's
pi
the,
over 7 pi over 6 and 11 pi over 6.
all right. Now you might think this is your answer, but you would not get any credit because you have to go from minus pi over 2 to pi over 2. So first of all, are either of these between this?
Yeah,
So 7
maybe.
pi over 6, maybe, yeah, maybe 7 pi over 6 is over here. So that's
Mm-hmm.
definitely not, that one's out. 11 pi over 6 is a better candidate. It's actually right there. So you go all the way
Mm-hmm.
around like that. So this is your answer, but not in this format. Okay, so like if you wanted partial credit, you could put in 11 pi over 6. If it were multiple choice, you wouldn't get any options. But you have to also know that there's another way to get to 11 pi over 6. There is the positive way, which we just did. That's 11 pi over 6. But there's also the negative way. If you go backwards, minus pi over 6, do you see that you also get to pi over 6 or 11 pi over 6?
Yeah.
Okay. And this is the one that they want. So they want you to convert 11 pi over 6 to minus pi over 6.
Okay.
So notice like neither of these fit what we wanted, but you can convert one of them because it was in the region. It was like just went the wrong way to get there. So let's try another one.
Okay.
Sine inverse of, let's see here. Let's go tangent. Pick one that's not too bad. Now we don't have time for tangent. Never mind. Let's go. let's go sine of minus root 3 over 2. Sorry, this is wrong. I'm so sorry. Oh, boy,
It's okay.
I'm just awful. 5 pi over 3.
It would be negative root 3 over 2.
Okay. So where is sine inverse negative root 3 over 2? So basically kind of again, where's the y value on the unit circle minus root 3 over 2? And you already know one of them, it's 5 pi over 3. But what's the other one?
4 pi over 3.
4 pi over 3. Okay. But again, you have to go from 0. I'm sorry. You have to go from minus pi over 2 to pi over 2. Do either of these fit that?
Um, Yeah.
Which one?
5 pi over 3.
Yes. So a better way I should have been asking is which one is in quadrant 1 or 4? And it's 5 pi over 3, which is there. But we can't go that way. So how do we go the other direction? How do we go? What's the negative angle to get there?
Pi over 3.
Negative pi over 3. Yes, this converts to negative pi over 3, and that's your answer. So that's what they're looking for that one. Okay, we'll stop the recording here. What's your game plan